Okay, so we've got a problem here, another ladder problem in statics. And let me just draw a ladder here for you. What's interesting about this ladder problem is that it's not going to be a maximum condition. In other words, the ladder is not on the verge of slipping. Instead, this angle is 78 degrees. The mass of the ladder is 140 kilos. So that's a pretty big ladder, right? So might as well make it a long one. The ladder is 8 meters in length to there. And also, so the center of mass obviously is in the middle of the ladder. And what we're trying to figure out is what is going to be the force of the wall, which is perpendicular, by the way, to the wall, and what is the force of the ground, the direction, and the magnitude. Now, you understand I'm hesitant to draw this force vector, and the reason why I'm hesitant to draw it is because at this point, I don't know if it's going to be like this or if it's going to be like this. One of these two. Don't make the mistake of assuming that the force vector is going to be along the ladder itself. There is absolutely no reason why the force vector has to be in the direction of the ladder. So you know what? I'm going to take a guess, and I'm going to say it's this internal angle here. Oops, wrong color. So there's my ladder, and there's my force. Okay. Now, if you'll notice, in addition, I have not drawn an angle. Is there a mu? There is not. And the reason why there is no mu is because this is not a maximum situation. The ladder is not on the verge of slipping. So we cannot use this equation because this equation is only for the situation where the ladder is just on the verge of slipping. So how do we do this? Well, let's come back and remember, we have to use summation in the x is equal to 0, summation in the y equals 0, and summation of the torques is 0 about some point. I'm going to pick point G, okay, because I know that there's going to be two forces here. I'm going to draw them in like a different color here. So I know this force and this force. We'll call this FGY, and we'll call this FGX. Those two forces are going to add up to be the red FG here. Or sorry, I should, just say FG. Okay? Now, let's start with the first one. You can see that there are only two forces in the x direction, and therefore, for this, we'll say FGX positive minus FW equals 0. Therefore, I can say that FGX equals FW. Done. Next, I don't know what FGX is at this point, but if I did, I'd know FW. Let's continue. What about FGY? Summation of the forces in the y direction must equal 0. So that's FGY minus MG equals 0. Okay, so I forgot to actually draw the MG, and it's right in the center of the ladder. Okay, assume a uniform ladder, so the center of mass is right in the middle. And now I can easily state that FGY is equal to MG. Okay. So far, so good. We can't finish the problem yet because we don't know what FGX is. And in order to do that, we're going to have to take the summation of the torques about point G. and set that equal to 0. Now, if I do that, if I take the summation of the torques about this point, I will immediately get rid of FGY and FGX because they act at the point. And the two forces that I'm going to have to include in my calculation are mg, which, by the way, I can move easily to here. That way I don't have to calculate. It's you know, 6 of one or half a dozen of the other. It's the same thing, really. That's a saying. But I can just move mg here. Whether I calculate the perpendicular component of mg here, or whether I simply move mg down and calculate the component length here, it's mathematically it works out to the same thing. Personally, though, I got to tell you, for some reason or another, I find calculating lengths easier than components of forces. So what is this length? Because I know that the force is going to be the full mg. Well, this whole thing is 8. That means up to here, I've got 4 halfway, 4 meters. But this, therefore, is going to be cosine 78 times 4. So I can say the force is mg times 4 cosine 78. That cosine 4 times cosine 78 is going to be that distance. Okay? So I can just write that there. 4 times cosine 78. I wrote it over the other force. However, is this going to be a positive or negative torque? Well, listen, if this is the point at which things are rotating and you are pulling mg down, or mg is down, that's going to create a clockwise rotation. Therefore, a clockwise rotation is going to be negative. So we have to put a negative there. Don't forget that. That's a very common mistake, okay? Next, we're going to move up to the other force, which is here. And we're going to go dot, 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 dot. And we're going to move this guy right to there. So now that is going to be acting there, Fw. And in fact, it is in line with this point. If this is 8 meters, this distance is going to be 8 meters times cosine 78. Okay? Because there's a 78. So that's going to be plus, and it is plus, I'll tell you in a minute why, Fw times 8 times cosine 78. And by the way, it's plus because this force is going to go counterclockwise about point G, and so therefore it's going to be a positive. Yes?
For force W, isn't it sine 78 rather than cosine 78? Like not down.
Well, Fw, I've simply moved it from this location here. I've moved it over here. We don't know what Fw is yet. All I'm doing is I'm multiplying Fw by the distance. Oh, yes. I'm sorry. You're right. I made a big boo-boo. The arm, thanks for catching that, by the way. The arm is the distance from here. Let's use brown for this. We're using a whole bunch of different kinds of colors. This distance has nothing to do with, remember, torque is equal to force perpendicular distance. So this distance is not relevant at all. It's the distance from here to here, which is in fact 8 times sine 78. Thanks for that. That's correct. Okay, so let's fix this here. That would be a sine. Now, let's go ahead and multiply this out. And that's going to all equal 0. Okay, so we can go ahead and figure out what FW is here. So FW is going to equal positive mg times 4 times cosine 78, and then divided by 8 times sine 78. Okay, so take this term to the other side, it becomes positive, and then divide by this term, and we get our answer. Let's plug in our numbers and see what we get. 140 kilograms times 9.8 newtons per kilogram times a 4 times a cosine 78 divided by 8 times sine 78 gives us, let's get out our trusty RPN calculator, 140, enter 9.8 times 4 times 78 cosine times 8 divided by 78 sine divided by, and we get an answer of 145.8. 145.8 newtons. Now that we have FW, if you remember from here, FG equals FW. So now we also know that FGX equals 145.8. And the only thing we have left to find is FG. We have the two components of FG, okay, because we know that FGY is equal to mg. And by the way, let's just calculate that mathematically. 140, enter 9.8 times, which is 1,372 newtons. So that's FGY, and we know FGX. So basically, we've got two forces, 1,372 and 145 gives us well, we can just go squared using Pythagoras, and then 145.8 squared, add them, and then take the square root, and we get an answer of, for FG, the hypotenuse, 1,379.7 newtons, and that's going to equal FG. No subscript there, that's just FG. But now we need to know the direction of FG. And the direction, obviously, well, we can either calculate this angle or this angle. Personally, I'd rather calculate this angle. So if we think of it like this and like this, this one's 145 and this one's 1372. So therefore, theta is going to be the inverse tangent of opposite over adjacent, and that's going to be 1372, enter 145.8 divided by, and then we go inverse tangent, and we get an angle of 83.9 degrees. Now, if we go back to the diagram, therefore mine was wrong. In other words, this one was wrong. It's actually going to be more than 78, so it's going to be out here at an angle of 83 degrees. Okay? Well, thanks for watching that. If we wanted to express the final answer, we would just say FG is equal to 1379.7 newtons at 83.9 degrees, like that. See you next time.